In this video, we'll be looking at how to solve similar triangles. So the way to solve, you actually have two methods, to either set up proportions or to use the scale factor. We've seen the scale factor before, where you just multiply one side of a triangle by the scale factor or divide it by the scale factor to get the other corresponding side. But in today's lesson, we're going to focus on proportions because I think this one just takes a little bit of the guesswork out of everything. So, example 1. Prove that the following triangles are similar, then solve for x and z. First of all, the minute you see the zigzag orientation, you want to use the angle and use those angle properties or angle patterns. All right, I see my parallel sides. So if I were to do a z pattern here, my z like this, then angle B and L would be similar. Angle B equals angle L. If I did another z pattern right here, then A and O would be similar. So angles across from each other are similar. And finally, C and C are the same because they are across from each other. They are opposite angles. And I like to write the last angle statement, even though this is the angle proof. Because when I write my similarity statement, I'm just going to take the letters as is. Triangle BAC is similar to triangle LOC. And there it is. Now, that was the proving. To solve, it's going to be really important that you match the corresponding sides. And I like color coding. So AB, which is made up of the blue and red angle, corresponds to LO. So the two parallel sides correspond. Then AC, which is made up of the blue and green, corresponds to CO, not CL. That's very important. And then finally, BC and CL. So the diagonals match and the parallel sides match. Now that we have corresponding sides, we're just going to set up proportions. And you have to be consistent. I'm going to make sure in my proportion, which is two fractions set equal to each other, I'm always going to put triangle ABC, that side length on top. Okay, so I'm going to do big over the small triangle. Now the first thing I want to do is pick a pair that has full information. My blue pair is no good because I have x and 1.4. My red pair, no good because I have an unknown. I have the z. But the green pair is perfect because I know both side lengths. So when I write my proportion, I'm going to start with 5.4 over 1.8 equals, and then I'm going to pick what I want to solve for first. So let's say I want to solve for x, then x pairs up with the 1.4. So big triangle over little triangle. So I just really, if you're color coding like I am, you're just matching the colors and setting them up in a fraction. Make sure one fraction has full information, like this one, and the other one has the unknown you're solving for. Once you have that, you're just cross multiplying. So I crisscross, and then the 1.8 gets multiplied by the x, and the 5.4 gets multiplied by 1.4. So 1.8x, I can't do anything with it, but 5.4 times 1.4 is 7.56. And then thinking back to solving a linear equation, we're just going to divide both sides by 1.8. And when we do that, we get x equals 4.2 meters. So there it is. And then I'm going to do the exact same thing with my other pair. So I'm still going to use 5.4 and 1.8, but if I want to solve for z, I'm going to make sure to use the 3 and the z. So 5.4 over 1.8 equals, and now be careful what you put on top. I'm putting the big triangle on top. 3 is in the big triangle. Z is in the little one. So sometimes the unknown is in the denominator of your fraction, and that's okay. And then we repeat the steps. So 5.4 times Z equals 1.8 times 3. I like to put the two numbers in brackets and not put an X, or else it might look like another variable even though it's a multiplication sign. 1.8 times 3 is 5.4. So we end up with 5.4Z equals 5.4. And when we divide both sides by 5.4 to isolate for Z, we get 1 meter. And here we are. You know, actually, if you were to divide this part, the 5.4 by 1.8, that would give you your scale factor. But this takes guesswork out of, should I multiply, should I divide? You just set up your two fractions, then crisscross. All right, let's try another example. And this time we're gonna have a triangle within a triangle. So prove that the following triangles are similar, then solve for X. So first of all, we need to know what our two triangles are. We have JPC, so this little triangle here, and then we have the big triangle on the outside. Sometimes it's hard to visualize where the two triangles are, but there they are. Let's prove similarity. Again, when you have the parallel symbols right here, right away, we should know that it's going to be the angle proof. And in this orientation, we're always going to use the F pattern. So if I put an F pattern here, kind of like this, then B and P would be similar, or would be the same measurement. So angle P, B equals angle P. If I do the F pattern the other way around, so like this, A and J would be similar. And then finally, angle C equals angle C, because this angle is in each triangle, the big one and the little one. So of course it has to match. And now for my statement. Triangle BAC, just going in the order of my letters, is similar to triangle PJC. Okay, now let's match the sides. Again, I'm going to color code. So AB, which is made up of the red and blue angle, goes with JP. And then PC is going to go with BC. Now I'm making this line outside the triangle so that the colors don't overlap and I can actually see. And then JC matches the entire length of AC. Be very, very careful here that you don't use, let's say, the 4 centimeters. 4 centimeters is this little portion. That's not the entire side length, so we have to be careful there. All right, let's see. I want to solve for X, and X matches the 5. So that's going to be a fraction. My blue pair has nothing. I don't know any of these side lengths, so that's pretty useless to me. But I do know that BC is 7 centimeters, and I need BC. I don't have BC. BC is not 4. That doesn't even make sense. How would it make sense that the bigger triangle has a smaller length? So to find BC, we're just going to add the 4 and the 7. So sometimes you have to do this little modification. So that's 11 centimeters. Now we have a full pair. And you can choose. I'm going to go the big outside triangle over the little triangle. So I'm going to write 11 over 7 for the first proportion equals 5 over X. So I paired up my corresponding sides, and then I wrote out 2 fractions for each. And now it's the repetitive part. We crisscross. So the 11 is crossed with the X, and the 7 is crossed with the 5. So 11X equals 7 times 5, which is 35. And then our last step is always to divide out that coefficient. And when we do 35 divided by 11, we get approximately 3.2 centimeters if we round to 1 decimal. And I use this squiggly equal sign to show that I am rounding. And there we have it. We reviewed some proving and we did some solving. All right, let's try another example here where we're not going to prove anything because I've given you the proof, and then we're going to solve for the missing side length. All right, so first thing, because we're not proving and we're given the statement, let's just match our angles so that way we can match the corresponding sides. Although after a while, when you see the same zigzag triangle orientation, the matching sides will always be the same thing. But here we go. P and T have to match, also because of the Z pattern. Q and S match, so I'm going to put 2 tick marks. And then R and R match. All right, so when I match my sides, PQ, which is made up of the red and blue angle, matches ST. So the 2 parallel sides match, just like before. The 3, which is made up of green and blue, matches the 6. And therefore, PR matches RT. So first of all, we're looking for X, which means we have to use the blue pair. If I look at my red pair, I have 5 and then I have nothing. That's useless to me. I need full information, a full pair. And my green pair has the full information, the 6 and the 3. So here we go, and let's set up our proportion. Now I'm just gonna I'm gonna mix things up and do the small triangle, which is on top, over the big triangle, which is on the bottom, just to show you it doesn't matter as long as you're consistent. So I'm gonna put the 4 over the X and then the 3 over the 6. I matched up my sides, they're in the same fraction, and sides in the same triangle are both on top. So 4 and 3 are on top, 6 and X are on the bottom. And now we crisscross. So the X is paired up with the 3, the 4 is paired up with the 6, so that 3X equals 4 times 6, which is 24. And then last step, which we've seen lots, is divide both sides by 3 and we get 8. And don't forget about your units for communication, so 8 centimeters. And then you can do a logic check. I mean, we wanted the side length to be bigger than 4 because we're in the bigger triangle, and it is. If you were to do this and you'd get a smaller side length, that would be your clue that you messed up somewhere. All right, for this next one, we're given triangle ABC is similar to EDC, and we're going to solve for X. So I want you to pause the video here and match up your sides, okay? And then come back to check your work before we set up our proportion. Okay, so angle A and D match. Angle B and D match. And then the C's have to match because they're opposite angles. Now this might help you, like showing the angles, but after a while, like I said, the 2 opposite signs will match. So notice they're both made up of the blue and red angle. And then each diagonal will match. So this one's made up of blue and green, and this one green and red. Now let's find our full pair. And that's going to be the 24 and the 6. Let's say we want to solve for X first. Well, X is paired up with the 22. So those are my 2 fractions. I just have to be careful how I set them up. So I'm going to do the left triangle over the right triangle, so big over small. So 24 over 6 equals 22 over X. 22 and 24 are both on top because they're in the same triangle, and then 6 and X on the bottom. Now I want you to pause the video here and do your cross multiplying to solve for X. Then come back to check your work. Okay, so 24 is matched with the X and 6 is matched with the 22. So 24X equals 132, and then we can divide both sides by the 24. And when we do that, we get 5.5 centimeters for X. So if you got that, wonderful. If you didn't, just check to see where you went wrong. Okay, now let's solve for y. So we need to make sure we're using our y and 5 pair. So I want you to pause the video and set up your proportion and try to solve for y, then come back to see if you got it right. Okay, so we should still start with 24 over 6 because that's still our full pair. And then make sure you have y over 5. Y is in the same triangle as 24, so we have to make sure it stays on top. And now, crisscross. So the 6 goes with the y, and then the 24 goes with the 5. So 6y equals 24 times 5, which is 120. And then divide both sides by 6 to get 20 centimeters. And there we go. So notice when you have these two triangles that are kind of rotated or they're zigzagging, use the Z pattern, the diagonals will always correspond and those two parallel sides will always correspond. Our final example is the triangle within a triangle. And for this one, when we do our corresponding sides, they're already oriented in the same position. So these two sides will match these two and then these two, but we'll show it with our angle knowledge as well. So P and P match, okay. Q and R match, so using that F pattern, and then T and S, okay. So QT, which is made up of the red and green, matches RT. So that's 8 and 12. That's a full pair. So I'm going to highlight that because I want to keep that in mind. And then QP, which is Y, matches RP. And I'm going to highlight that entire side length of RP so that I don't mess up in the future. And then the 10, so PT, matches PS. Now please keep in mind here that this 10 does not correspond to X because X is not the entire side length. X is only this little portion here. So if we're starting with X, X is part of PS, the big side, and PS is made up of the 10 and the X together. So sometimes we have to write a little expression. So you have to be really, really careful. X corresponds to this, which is not even in a triangle. It's part of a trapezoid. And these are not similar trapezoids. They're similar triangles. So I have to add the 10 and the X. Just like in a previous example, I had to add two numbers to get the side length. Here, we don't know what X is. Okay, let's write our proportion. So we have the blue pair. So I'm going to do 5 over 12. So inside over outside triangle equals 10 over 10 plus X. It looks a little bit more overwhelming than the other one. There's just going to be one tiny tweak. So let's crisscross here. The 5 is paired up with the 10 plus X. I'm going to write the 10 plus X in brackets, which just shows you're going to have a little bit of distribution to do. And then the 12 times 10. So here's a little bit of grade 9 distribution. Just multiply the 5 in. 5 times 10 is 50. 5 times X is 5X. And then 12 times 10 is 120. And we know how to solve linear equations. We want to isolate for X. So let's start off by bringing the 50 over. So at this point, it's nothing new. 120 minus 50 is 70. And then when I divide both sides by 5, I get X equals 14 centimeters. And that makes sense. Now this isn't very proportional, but that's okay. Okay, let's look at our red pair. So we're still going to use the 8 and 12 for the blue pair, but we have Y, and then PR is Y plus the 4.5. So similar idea. So I'm going to do 8 over 12 equals Y is in the inside triangle, Y plus 4.5 is in the outside triangle. Yes, I have variables on top and bottom, but But when we crisscross, it will still look familiar. So even though there's something that looks a little iffy, there's still familiarity to this style of question. So crisscross, the 12 goes with the y, the 8 goes with the y plus 4.5, which I put in brackets, which just tells me that later on I'm going to do some distribution. So 12y equals 8 times y, and 8 times 4.5, which is 36. I have y's on opposite sides of the equal sign, so I want to bring them together. And no problem, I can bring the 8y over and it becomes negative. Because remember, when something moves over the equal sign, we switch its sign. So 12 minus 8 is 4. 4y equals 36. And when we divide both sides by 4, we get y equals 9 centimeters. And there we have it. Now just keep in mind, these triangles, they're not to scale. Okay, and that's it for similar triangles. So to solve them, we're just doing proportions, so something familiar, which will result in that linear equation. The hard part is really just making sure you pair up the sides correctly. And again, in your zigzag, your diagonals match and your parallels match, and the triangle within a triangle, everything that overlaps matches. Now just be careful, with sometimes having to do that additional addition step. And that's it for solving.